Hello there. My name's Dick Wall. I've been using Scala for quite a long time now, about 15 years. I actually got turned onto it around about the time that Java 5 was sort of stagnating and wasn't going anywhere, and a friend of mine said, hey, you should check out this new language called Scala. I think you might like it. And I did, and the rest was history. I'm going to talk a little bit today about tooling for Scala. I've been also training people in Scala for probably a dozen years now, and in the training up until a few years ago, I recommended IntelliJ IDEA as the easiest way to get into Scala development, and in many ways it still is. It's an excellent product if you like and are happy with IntelliJ. I'm not going to try and convince you to move, but I over time, or just recently, in fact, over the past few years, VS Code has really come on in leaps and bounds with a project called Metals, which is the meta language server. And I use that pretty well exclusively now during my work and also for the training that I do. So today we're going to look at VS Code. This is a warts and all sort of introduction. I'm not pretending everything's perfect. In fact, one of the things that is interesting is many people come to VS Code assuming it's going to be lighter weight or faster than IntelliJ, and that's not really the case. The problem here is that Scala is a very complicated language. Well, not complicated, it's a very capable and powerful language, and the compiler takes a long time because it does a lot of work for you. Switching to VS Code is a matter of preference, but it's not going to suddenly make everything much faster. It's actually a bit of a wash as far as performance goes between IntelliJ and VS Code in my experience. But there are other advantages to it, one of the main ones being that VS Code uses the real Scala presentation compiler, which means there are less surprises, particularly when you start doing very in-depth type-level programming and stuff like that. Anyway, so let's take a look at VS Code. I did want to mention this does assume, this video, that assumes that you already have SBT installed. You follow instructions online for how to do that, and also that you've downloaded VS Code. I mentioned IntelliJ. Do check out IntelliJ if you're looking for tools. Don't just take my word for it. Give them both a go. But you can download Visual Studio Code from Visual Studio or code.visualstudio.com. Download. You'll find it for the platform of your choice here. Also, if you run Linux, you'll probably find that it's in one of your software stores or whatever. You can find it in all sorts of different places. We're going to assume that you've installed that, and then we'll talk about how you get it working from there. As I've already mentioned, this does assume that you have installed SBT and you have that running. This is not going to be a tutorial on getting the whole tool chain up and running. This is really about VS Code, but I'm sure you can find plenty of instructions online. Then the chances are, if you're interested in this, you already have SBT up and running. SBT is the Scala build tool. That's actually technically not what SBT stands for. It doesn't stand for anything anymore. But that kind of works. Anyway, so what we're going to do now is use that to create a new project that we're then going to use Metals to install. So first of all, let's create that project. And for this, I'm going to use Giterate, which is the fastest way to create a new Scala project, the easiest way to create a new Scala project. So you just say SBT new Scala/Scala 3. I'm using Scala 3 for this .g8. And it's going to ask you what name you want to use for this project. So we're going to go with, when it asks me, VS Code Demo, and it's done. So if you look now in the, if you look in VS Code Dev, VS Code, if you look in here, there's VS Code Demo. We can go in here, and this is ready to go now. So what we can do is say SBT test. And this will build it for us. So far, we haven't done anything with Visual Studio. This is just getting it built and running for the first time. So once this is done, we should see a successful test run. Yep, that worked. And it says that that's an example test that succeeded. Okay, now we're ready to go with Visual Studio Code. So if we have a look at that, you'll probably, when you first bring it up, see something along these lines. The first thing we're going to want to do is install the extension for metals. So if you go into the extensions sidebar here and type metals, up comes the Scala Metals. You want this particular one. You can see I've already got it installed. You would type, or you would hit install here. There's a couple of other things that I'll recommend while we're doing this that you might like. You'll probably have the Scala official syntax already installed. Some of the other things I like, Scala snippets is pretty handy. So that's worth having. Don't put the Scala SBT extension in. It's not needed in the best case, and in the worst case I've found that they sometimes get a bit confused over who's doing what in terms of metals and SBT, so it's best to leave that one turned off. You don't need it. All of these others you can look through, but these are really the ones that you want to get to, and if there's time at the end, maybe we'll talk about some of the other extensions that are handy to have. Now that we've got metals installed, it's time to import that project that we created. So for this, you can go to File and Open Folder, and then navigate to the thing that you created, and you just open the folder. So open the whole folder. Now, the first thing it will say is, actually mine's already warmed up. Oh yeah, there we go. Starting the metals server, it says here. So it starts the metals server. Second thing, it should come up and ask you this automatically. So you can say, do you want to import the build? I'm going to go ahead and say yes. If that doesn't come up, you can come over to the side here and you'll see an M in the side, and this is the metals menu. If you go under here, import build is one of the options there, so you can force it to try and import the build from there. All right, once it's done, we should see, oh yes, I can show you quickly here. Down at the bottom, there's a these icons that you see here. This is kind of the I/O, the console part of the thing. And if you look under output, the drop down here, you'll see that there's a metals option, a metals drop down. And if you look in here, this is the log from metals, and it should look pretty healthy. It looks like it's finished importing. There weren't any obvious errors. So everything looks ready to go. And now we can start to use metals on our project. So you might notice that my icons look a little bit different from yours. This is because I've imported the material icons extension as well. It just makes things look a little bit nicer. There's no real extra functionality to it. It's just nicer icons. But what we can do now is start to look around at the Scala source code. So if I go into the source here, which is where SBT keeps its Scala code, and I double click on this, you'll see that we get up the Scala code here. This is the Scala 3 way of defining main methods now. So you have an @main annotation, and you just define a top-level method for it. And so this is all of the stuff. If you want to check yet whether metals is working and is happy, just hover over something like printline, and it should give you the type signature of the method. This is hover help. And also the Scala doc for it, so it says exactly what it does. You should see this, and that's an indication that metals and VS Code are configured correctly and ready to work. You can also do it over hello for unit here. You can hover over the message, and it tells you that that's a string, all that sort of thing. Hopefully, you'll also notice a run and a debug at the top, and you can hit these. If we hit the run, you'll see that it actually runs and says, hello world, I was compiled by Scala 3. That's this up here. You can also run it with debug, and if you do that, it runs in the debug console. Now, we're going to come back to the debugger later, but for now, just try those two things and make sure they work. The other thing that you'll find in this generated project is a test suite. In this case, it's using munit, which is a very lightweight, fast test framework. This also works the same for specs and Scala test. Scala test is the one I tend to use. But what you'll find is that you can run all the tests, or at least for munit and Scala test, you can run individual tests in here. And that's what these icons are for. You can also right click on them and just say debug the test here as well. So if we want to debug that test, we'll run it here, and you'll see that that worked. Another thing worth mentioning at this point is the Test Explorer. If you look at the side, you'll see a Flask icon. And this is the list of tests in your project. And you can see that it ran that one. If I add a new test here, and I'll say example test that fails. Incidentally, just worth mentioning here, I've been experimenting with something called Copilot, which is sort of an AI Scala auto-completion tool. Well, it's not Scala, it's from GitHub, and it tries to anticipate what you're going to do, and it's successful a fair amount of the time, but you really do need to check its work. It gets things wrong. So in this case, I've got an example test that fails, and what we've got now is an obtained and an expected that are different. I'm just going to hit tab so that completes. Now, if I save this, the first thing you should see is this one comes up with the ability to run it. And if I run the whole thing, we'll see that the first test succeeds and the second one fails, and it tells you why it fails in here and also down at the bottom here. So we've got an easy way of seeing tests that are passing, tests that are failing. I can also go straight to the code that failed here, and so on, and pretty much what you'd expect out of a test explorer. Now let's have a look at some of the things that you can do with the tooling, the IDE here, and these will be kind of what you expect. Oh, by the way, yes, hover help again. Useful for all sorts of things. Tells you the type signature, gives you the Scala doc, and you can scroll it if you need to. So let's have a look, for example, at code completion. So if I create a new test here and show off code completion, and then we'll do something along the lines of, it's still trying to help me here, but I don't want that particular thing. So let's say val x's equals list 1 2 3 4 5, and then I can say x's dot, and if I say reverse or start typing, first of all I can just hit dot, and actually if you press control space you can force it to come up. So it's giving me all of the methods that it knows about that can go after this, things that we can do. I could do something like partition, and it's actually very smart because that was what I was going to do. So partition even from odd numbers. So I can say val even comma odd equals, and save that. And then I can say even dot size should be and this should be what is it? There's 2 even numbers in there. Odd dot size should be 3. Okay, and let's save that. And now we should, now this is one of the other features that we've got, real-time error checking. So this is telling me that value should not, is not a member. Okay, so we cannot do this. What we need to do, this is Scala test bad habits coming through. This is how I would do it in Scala test with matches. What I want to do instead is say assert equals, and by the way, the code completion there was Copilot, not metals. So if I say that, assert equals, and then assert equals odd dot size and 3, and when I save, it should update and it should be happy with those. There we go. Now it's happy to go, and now we can run this test. So let's check it. And indeed, that one ran. Let's take this one out for now, so that it's not showing up as a failure. And we can run the whole thing again just to show that, in fact, both tests pass. There we go. So both tests are passing. Again, the hovering works. Another thing that you get in addition to the errors, and I'll show you that again. So if I say something like equals ish, that's not really a thing. Now we get the error. You can hover over it, not found, so it tells you that that's not found. It also shows up in the problems list here, and you can go immediately to those problems to fix them. Another thing, it shows you warnings. So down here I can say X's are match. Now there's some nice features in it. Match exhaustive here is code completion that gives you in cases where these are sealed traits, where it knows all of the combinations that can be matched, it will actually give you matches that match everything. Now I'm going to force it in this case not to match a particular case. So I'm going to say first and then second and next. And this means that this will match a list of at least 2 items. This will match an empty list, but there's no case for the just one item in there. So if I say println 2 or more and 2 or more elements, that's fine. And println empty. Yep, that's exactly what I want. Okay, now if I save, we get a warning here. The warning is that the match may not be exhaustive. This is the compiler doing this, but vscode is picking it up. So down here we see match may not be exhaustive, what you'd expect. We can go ahead and fix that by saying case first and then nil. And there we go, print 1 element. Now if I save this, the warning goes away. So pretty much what you'd expect out of errors and warnings, compile time errors and compile time warnings. Worth mentioning again, this uses the Scala presentation compiler, which is the first 4 phases of the real Scala compiler. So this is pretty nice because you really aren't guessing. This is Scala telling you what's right or what's wrong. It doesn't catch every possible compiler. There are things that can happen further down through macros and things like that. But it doesn't give you, it tends not to give you false positives, which is something that you occasionally do see in IntelliJ still, particularly when you're doing type level programming, things involving a lot of depth in the type system. So that's a nice feature of this, is the presentation compiler. We've also got go to definition. So there's a number of ways I can do this. One of them is if I want to, let's say I'm back at the main here, I can say control or command on the Mac P. Now I can say search files by name, and if I say my suite, that shows up in there, and I can go straight to that definition. So that's pretty nice, being able to just instantly jump to one of these. Another way I can do go to definition is hold down control or command on the Mac, and you'll notice that when I do that, this becomes a hot link, as well as telling me the information about it, the partition. It shows you that you can click on it, and that takes you to the definition in the source code of that particular method. We can go further down. So this also calls super partition. This one calls result, and so on. You can go through, and if you want to go back, there's a key binding for that. It actually depends on the platform you're on. The default on Linux is Control Alt and minus, and it's just Control minus on the Mac, I think. So this lets you back out to where you were previously. So pretty nice go to definition. Another thing you might want to do is create a new file, a new class. Now there's several ways you can do this. You can just create new file, or you can create a new Scala file. So if we want to say a new Scala object, so this is the type of thing that we're going to create here, a new object, and call it foo, and it gives us the Scala foo here. Now let's say, for example, I want to do something like, just for the sake of it, I'm going to make a add async, and this is going to return a future of int. Now that's fine. Future 1+1 is fine. If I save this now, you'll notice that it's got a problem. It hasn't found future. But if I come back up here, one thing I can do is actually say, just type it again, or I can hit Control Space, and it looks for where the future that I'm looking for might be coming from, in this case Scala concurrent. And if I choose that one, it will add the import automatically at the top. So if I save again, that problem goes away. We have another problem here. We don't have an implicit context. So now I need to say import Scala concurrent, and again code the GitHub code lab thingy is anticipating what I want. So I want to import the global implicit. That should make that work, and sure enough, now we have everything happy. It's figured out what I needed to do and fixed it for me. So very nice experience there. That's how you create new classes and objects and things like that. I can also refactor things. So I called this X's, but maybe I want to refactor it and call it numbers. So I can say rename, and we'll say numbers. And if I hit return there, you'll see that it updated them all the way through all the places. So basic refactoring. Another thing I can do here is take this and extract it. So I can do refactor, and there's various refactorings that come up at different places, but I'm going to extract the selection as a method in here. It calls it new method. Again, I can rename this. So let's call it, it can't be renamed. All right. Let's rename it here. Rename symbol. Okay. Right, that's misbehaving right now. We'll come back on that one, but I can just call it match numbers. And down here, I would say match numbers. And save. And now we can run again, make sure everything still works. So there we go. All right, so that's the refactorings, basic refactorings. One last thing is to talk about the metals panel again over here. We're going to talk about what happens when things go wrong in a bit. But one of the things you can do is if things start to misbehave, you can either try a clean compile or restarting the build server from the side here. So if I do a clean compile here, you'll see that it does the work over here, and it says, yep, going ahead and creating the or recompiling the thing. So good. Another very useful feature of vscode is worksheets. So I'm going to show you those here. I usually create them in a top level folder here. So let's do that. So I'll go ahead and create a incidentally, if you ever get into this where you want to go to the top level, you can just select one of the folders and then hit escape. I'm going to create a new folder and call it Worksheets. And under here, I am going to create a new file. This is the way I normally do this. And the new file is going to be called demo.worksheet.sc. That naming is sort of important, particularly the .worksheet.sc part. This is how VS Code picks it up. And what this is kind of a live coding environment. So I can say something like val x's equals 1 to 10 by 2. And if I hit save on it, you'll see that, in fact, it evaluates it straight away, and it adds this as a virtual comment afterwards. So now I can say x's.map, and then, yep, that'll do. Multiply everything by 2, and you'll see that that comes up as the answers there, 2, 6, 10, 14, and so on. I can say val mults equals, and it still shows me the result on that thing. And I can also do things like println. So mults dot for each println, and save that. And when this runs, what you'll see is that it actually gives you a hover tip, so you can hover over it and see what the output is of that particular thing. It gives you the ... to show you that there's more than just that one answer there. And that's just to keep everything lining up. So that's worksheets. They're very handy. In the next bit of this, I'll show you a bit more that you can do with them, because they are really quite powerful. So I mentioned that worksheets can do quite a bit more than just simple evaluations like this, and for that I'm going to open up one of the training modules that I have. So we'll do exercises advanced here. This is this is part of the training course that I do, and if we want to go down to, say, let's go to functional programming. Yes, the monad patterns one is probably a good one to start with. The reason I'm picking this is that this actually uses third-party libraries, and you can import those using this notation. So you kind of do this $dep and then backticks, and then this is org type level, and then cats core 2.6.1. So this is importing cats core and cats effect from the libraries. And this : notation is sort of the same as %% in SBT. So these colons are replacing the percent. So this is basically the organization, the project name, and the version. And it then imports those libraries from Ivy or Maven, your Artifactory, whatever you've got configured. You can then use them. And so, as you can see here, this is actually importing a bunch of different cat stuff that we're going to use for cats.io. And down here, we can actually see again that this is really using the methods giving you the results, and you can hover over them and see what happens when this worksheet runs. So these worksheets are super useful. I use them all the time. In fact, the Advent of Code that just recently finished, I pretty much did the all of the exercises. I just did them in the worksheet because it's so fast to immediately save something and see the result. If I introduce a deliberate problem in here like this, you'll see that this immediately gives you compile errors, or I can say something like, if I want to say here, oops, require name length is greater than, and if I say it's greater than 6, and name must be at least 6 characters long. If I save this now, you'll see that this fails, so that it shows you in the worksheet the failing line and what the problem was. So the name must be at least 6 characters long. That requirement failed. So really nice feature. Really, I used to use the REPL all the time, and now these days I find I just fire up a worksheet and try stuff out in there, and it's really quick and easy to do. At this point, I should say that this is not going to be an exhaustive tour of VS Code and Metals. There's a lot of features in there. I recommend that you look at the Metals page and the Metals information for the extension. There's a lot of stuff listed in there, what they can do. But I'm going to show you a few more things, and in particular, how you can find out more about what Metals can do. So first of all, if I hit Control-Shift, or this is Command-Shift on the Mac, and P, this brings up the command palette in VS Code, and you can just start out by typing Metals, and this is a list of all the things that Metals can do in the command lists here. So there's a lot of different things that you can have a look at. I'm going to show you a few of my favorites now. These are very handy when you start working with implicits or more deeply with types. You can toggle showing implicit parameters, implicit conversions and classes, and showing the inferred type. So let's start with the inferred type. If I toggle that on, you'll see down here a bunch of extra comments now, or extra annotations. These are not really in the code. You can't select them. It just skips over them. But it's showing you what those types are. So it's saying this is going to be an int in this pattern match. Down here, this is a obscure math util is the type here. This is showing you that the should, in this case, this is Scala test, is doing a long match against the value there, and so on. So this is a handy little thing that you can turn on or off. Let me turn that back off again. Then there's inferred type, or implicit parameters. So if we turn that on, you can see this is the implicit parameters that are being applied to some of these methods. This is Scala, the way Scala test works. We can have a look at some of the others in here. Let's see if the extractors probably has some in. No, let's try one of the Scala files in here. So something like JSON solutions. We should see some of them in here. Yeah, here we go. So when we say something like "get me the book," this is the implicit parameter that it's using for that, which is the book JSON format from up here. And so you can see again, I can turn those off. So turn off the implicit parameters, and the last one is the implicit conversions and classes. So if we look at that, to give you an idea of one of those, if I come in here and I say 1 to 10 by 2 and save that, now you can see this is what's actually going on there. This 210. This method 2 doesn't exist on an int, but it is bringing in the int wrapper which turns it into a rich int for this. And so you can see that that's giving us the implicits around it, and I can again turn that off. So have a look through the command palette in VS Code, Metals and other things as well, and just see that there's a wide selection of functionality available through that, and you can bind them all to keys as well. So very easy to set up the ones that you use most commonly to key combinations. All right, now let's talk about the debugger. This is something that has improved radically over the past couple of years. The debugging story in IntelliJ was, in VS Code was not one of the best going back a couple of years. And in fact, I used to start up IntelliJ when I needed a single-step debugger, just because the IntelliJ one was so much better. But that has really changed recently. So the debugger is pretty much what you'd expect, at least in use. So what I can do, for example, is down here, I can say I want to stick a breakpoint down. You'll see the breakpoints when you hover over the margins here. So you can stick a breakpoint down, and then I can just say, okay, I want to debug this test. So let's go ahead and debug that test. So now it's going to run that in the debugger. You'll see it come up in the debugger over here, and it's hit the breakpoint. Now, this is where things really start to heat up, because if you look over here, first of all, I can do some exploration in the sidebar. I can see some of the things. This in tests tends to be a bit overloaded. There's a lot of different methods and values defined in it, but I can see the values that I want to look at in there, and if I hover over it, I get the completion. So this is the whole JSON library string. But I can do a lot more. This is probably the best part of this for me now, is we have a full REPL in here. So I can actually say something like, now this JSON has been imported here. So I should be able to just say json.parse, and we get code completion in here. And if I say JSON parse JSON library string, and again, we get that, and hit return, you'll see it gives us the JS object that we've got. Now I can do more with this. I can then say, let's pull out items and try that. And that gives me the list of items. And we can do pretty much anything that you do in the code in the debugger here and look at it. At any point, I can clear this out. Clear the console and just run it again. So one of my favorite tricks is on if I'm really trying to track down a very difficult state bug somewhere, and I've got some kind of input coming in from another system, I don't know what's going on, I can get it into a form where I can print it out into some kind of structured state, get it out here, and then just copy everything and put it into another window. So let's actually try this here. So if I say copy all, create a new window, paste it in there. I want to get rid of the, this is actually a list, so I don't need the whole list. But what I can do at this point is say, let's get rid of this end bit. And then I should be able to say this is JSON and format document. And sure enough, we have now formatted JSON out. That makes it a lot easier to see what's going on and get an idea. So this is really nice and powerful now. You can also do conditional breakpoints in here. So you can edit the condition on the breakpoint. We could, if it was a value like an integer, we could say only stop if x is greater than 100 or something like that here. And pretty much exactly what you'd expect. It's come a really long way in terms of the debugging, and these are your commands. So this is like just run continue, step over, step into, step out of, rerun the whole thing from the start, and disconnect the debugger. So let's do that one now. So yeah, this has really come on very, very nicely. There is the occasional gotcha that I've seen where it stops and it seems like there's no reason why it just stopped. And if that happens to you, what you want to do is head over to the debugger, and in the run and debug, I didn't run it, I just ran it, not debugged it. So let's debug. So when it stops, what you want to do is actually come over here, and one of these will say pause. At least one of them will say paused on a breakpoint. If you go into that and click on it, it then takes you to the place in the code where it has stopped. So there's some kind of glitch where occasionally it doesn't automatically take you to the breakpoint. That's an easy way of fixing it. Just look for the paused thread and select the location in there. Now, I promised you that this would be warts and all, and I'm going to live up to that. So there are still things in Metals and VS Code that go wrong occasionally. These tend to happen. Actually, let me tell you how they manifest, first of all. The first thing you'll see often is that you have a particular exception or error, and you try and fix it. You do what you think fixes it, and indeed it looks like it should be fixed, but there's still like a red or a yellow marker on there, and basically the information has fallen behind. The way you can usually tell this is use SBT to compile it, and if SBT is happy with it, this is a macro example, so that doesn't matter, but if SBT is happy with it, but Metals isn't, then there's a good indication that something's wrong. Another thing that happens is the debugger won't start or it won't run, or just there's another particular case where it seems to rebuild everything from scratch every time. It gets very slow to build. All of these tend to show up under the output. So if you look under the Metals output, you'll quite often see exceptions listed in here or other errors. Quite often it's things like it's run out of file handles or stuff like that. It can be any reason. Now, what tends to cause these things? I've come across the two primary ones. I'm sure I don't know them all, but the two primary reasons are either Metals or Bloop gets updated in the background and a new version gets downloaded, and something about the old token database and the new implementation, they don't click, and it starts giving out problems there. Alternatively, it happens quite often if you grab an update from GitHub or something like that, and your tokens change that way, and it ends up with stale data in the semantic database. And in both of these cases, there's a few things you can try. You can head across to the Metals thing, and you can say restart the build server if you want to, and you'll see down here it restarts Metals and Bloop. And then we can say, there we go, that worked. And then you can try a clean compile. This sometimes works, and it's a quick thing to test. So, go ahead and try that. If that clears up the problem, then great. If it doesn't, you may have to get a bit more determined about it. And here's what I do for that situation. So let's say we're still getting problems. We've tried a clean build and things are not happy. The first thing I do is hard quit out of the VS Code. So let's exit the whole VS Code, and then I come in here and I say kill all Java. So this kills SBT, it kills Bloop, it kills anything that's still running. If I run it again, it says there's no processes found, so I know that they've all gone. Next, I have a little program that I've written, which is very, very useful. It's called SBT nuke. And it basically just does this. I'll leave it on the screen for a minute while I talk, so that if you need to, you can grab it or write it down. But basically what it does is it finds all of the target folders in a directory, as well as the Metals and Bloop files, and it removes them. So we can say SBT nuke. Okay, now run this in the project that you're having trouble with. Do not run it at the top level. It could delete too much stuff. I'm not responsible if you delete too many things with this. Just do it in the project directory. So we do SBT nuke. You can ignore the warnings, that's fine. And then after this, I recommend just saying test/compile, or just compile is fine. So SBT compile. This will now run everything again. Make sure that everything builds. And once this is done, basically what we did was we wiped out all the caches just now. So we've forced it to do a completely clean build. And then finally, you can restart VS Code. And now VS Code's, it should come up with the project open again, but it will realize that you don't have the Metals server running and you haven't got the project imported anymore. So once Metals has started, it should come up and say, do you want to import the the project. So give it a second here while it thinks about it. And it said, oh, it actually figured it out. Oh, I was in the wrong one. That's why. Let me go through that again. Doesn't hurt to repeat. This is because I nuked the wrong project. So if I come out of here now, exit. So we'll do that again. Kill all kill all Java. And then the actual one that I want to kill is Scala Advanced Training. And exercises advanced, and then SBT nuke here. Okay, so once again, you can ignore all those warnings. SBT compile. Let it do its compilation. Again, worth taking the time to repeat this. This doesn't happen all the time. In my work, I find I end up doing this little dance maybe once every couple of weeks. I just keep it around. You'll get used to it. IntelliJ actually has a nicer way of doing this, which is invalidate caches and restart. This is effectively what we're doing here. It's just a little bit more manual. So now that that's happy, I can start VS Code again. It will do the same thing. It will start up. It will load metals. It will run through its import, and then it will say, yes, there we go. New workspace detectors. That's because I wiped it out. So I just say import build. And we wait for it to finish here. And then everything should be back to normal and we can carry on with working like we were before. And this fixes, I usually just skip everything else. If it doesn't, if restarting it from the metals menu over here, if restarting the build server and doing a clean compile doesn't work, I just skip immediately to this hard reset of everything. And if it's a big project, it may take a couple of minutes to re-import. It's still more time effective than trying to figure out what went wrong. Just start over. It's have you tried turning it off and on again, basically. And in the meantime, go and make yourself a cup of tea because you deserve one. And that is pretty much all I've got to talk about today. I hope you like VS Code. Give it a try. As I say, there are still warts with it, but it's come on really well. I think the only way it's going to improve is if people continue to use it more and report their bugs. There's a very welcoming, active community around it on Gitter, so you can find that and talk to people. In the past, for example, an update was leaking file handles, and I tracked down that particular problem and I said, hey folks, this is actually an advanced release of it, a beta release that I was using, and I approached them and I said, I think there's a file handle problem here, and I kind of showed them the evidence, and I handed it off, and they were very nice about it. They said, thank you ever so much for finding this before it hit the mainstream. They immediately found the change that had caused it, and that just headed off like what could have been a problem. It was when you started the debugger, and basically it was loading lots of class files and leaving the file handles open. So on a large project, it just ran out of file handles. And so yeah, talk to people. It's a nice welcoming community, and we can all help make this tooling better. And community tooling is really important. I'm not going to say, you'll never hear me say a word against IntelliJ. It's a great product, but in all ways, competition is good, and we have to, we want to keep a vibrant volunteer or open source tooling story for Scala, if only to make everybody keep improving their stories for this. All right, I hope this was useful. I hope you give VS Code and Metals a go. Oh, I mentioned I was going to talk very quickly about some of the other extensions that I've got installed. So I mentioned Copilot. This is just something I'm experimenting with. It's actually pretty neat. Git Lens is great if you haven't used that. It's a nice way of keeping Git managed and organized. There's themes in VS Code. I've got various themes installed. There's the Jupyter, I'm sure you've heard of, is a notepad thing. More themes here. Plant UML. If you use Plant UML for stuff, you can use that. I also do development in Python and Rust occasionally, so those are plugged in. Sort lines is a pretty nice one. This one I can't say enough good things about. We use base 64 for various encoding jobs internally just to represent binary data in a way that it can be put into databases easily and stuff like that. This lets you select a chunk of base 64 and decode it, and change things in it and then re-encode it. Very handy. And YAML support, things like that. You'll probably find that you end up using YAML if you use pretty much any of the cloud offerings these days. And there's a lot more. It's a very active environment for plugins. You'll find a lot of different stuff. If you can think of it, you can probably find it in the vscode extensions. All right, thanks, and best of luck with your Scala coding.